So far we've been looking at SOHCAHTOA, right angle trigonometry. So when you use sine theta is opposite over hypotenuse, cos theta is adjacent over hypotenuse, or tan theta is opposite over adjacent, you are only using right angled triangles. For the next week, we're going to look at 3 rules: the sine rule, the cosine rule, and the area of a triangle rule, and they are to be used only in non-right angled triangles. So, for example, if I have triangle ABC, and if this is a non-right angled triangle, I'm going to derive the sine rule in a few minutes. At the moment, you don't know what the sine rule is, but we're going to derive a rule, and that will be called the sine rule. And it's quite easy to use. So, here I've got triangle ABC. I'm just going to put a dotted line down here and put this point P here and call this H for height. And if this is a horizontal line here and this is a vertical height, I'm just going to put a right angle there. So I've got a right angle there and obviously a right angle on the other side of that triangle. So if this is vertex capital A, the side opposite it is small a. If this is vertex capital B, the side opposite it is capital B. Lowercase b, sorry. So capital A, lowercase a, sorry about that. Capital B, lowercase b. And now I'm just going to, if this is capital C, this whole side would be lowercase c, but I'm not going to use that side at the moment. Okay? So what I want to use are the 2 right angled triangles here that I've drawn. Okay, so if this is vertex A, how would I come up with an expression for sine of A? Sine of this angle, what would it be? In the right angle triangle. See, if I want to use sine, cos, or tan, sine is opposite over hypotenuse. So what is it? Sine of A is? Good. So sine of capital A, this angle there, is opposite over hypotenuse, which is H over B. So I'm just going to make H the subject of the formula. Therefore, H is? No, times B. So H divided by B, opposite of divide by B is times by B. It would be sine A times B, or I'm going to write B times sine A. Okay, opposite of divide is times, so it would be B times sine A. So that is in the right angle triangle, so that's using in triangle APC. In the right angle triangle APC, that's a right angle, sine of A is H on B. What we're doing here is we're deriving the rule, okay? Now, in triangle, I'm going to use the other right angle triangle. In triangle BPC, what would sine of capital B equal? In this right angle triangle, it's H over A. Come up with an expression for H. H, so opposite of divide by A is times by A. So it would be A times sine B. So we've got 2 expressions for H here. H equals B times sine A, and H equals A times sine B. This is like we're solving simultaneous equations. If H is this and H is that, what can I say is equal to what? If these 2 things both equal H, aren't they therefore equal to each other? So I can go, therefore, B times sine A equals A times sine B. All good? H equals that, and H equals that. H is this length. If they're both equal to H, then they're both equal to each other. A, capital A, if you see a capital, it's an angle. If you see a lowercase, it's a side length. So capital A and capital B are the sizes of these angles, okay? Little a and little b are the side lengths, and small h is also a side length. I've just come up with 2 expressions for the side length, h. H is the same thing. H is b times that. H is a times sine b. So therefore I'll put them equal to each other. Now I want to rearrange. Now if I divide both sides by b, what do I get? If I divide by b, both sides, what do I get? Sine A equals A times sine B over B. If I go divide this side by b, divide that side by b, that's what I would get. Or if I just take the b down to the other side, that's what I would get. I also want to divide both sides by sine b. What would I get? Divide by sine b, divide by sine b. What would I get? I would get sine a over... Actually, this is not the way I want it. One sec. Can we just abandon that for a sec? That's not the one I want to move. So just get rid of that last line. Sorry, girls, not thinking. I want to not move the b. I want to divide through by sine a. So can we do that? Actually, I want to divide through by sine a and sine b. So let's do that. Sorry, girls, wrong rearrangement. So let's divide both sides by sine a. What do I get? What do I get if I divide both sides by sine a? I would get b equals... Actually, can we divide by sine a and sine b together? I want to divide by sine a and sine b. So I want to divide both sides. So I'm going to put both sides over sine a and times sine b. So I'm dividing both sides by sine a sine b. And I'm dividing this side by sine a sine b. Okay? So I'm dividing both sides by sine a sine b. What do I get? Anyone? What would cancel? The sine a's would cancel, and you get b over sine b equals, what would cancel here? The sine b's would cancel. You would get a over sine a. Now, girls, sorry. Okay, so I've got this expression there, b times sine a equals a times sine b. What I did was divide both sides by sine a times sine b. That's what I just did there. And the sine a's cancelled. Why am I allowed to cancel? Because they're all what sort of symbols? Multiplication symbols. I don't have any pluses or minuses there. I'm allowed to cancel between the numerator and the denominator. The reason I'm dividing by sine A sine B is that I know I'm trying to get this result. B over sine B equals A over sine A. Okay? That's the sine rule. You won't have to derive it. I've just derived it for you. Okay? So all you've got to do is learn the rule and use it. Okay? But syllabus says we have to derive it. Okay? So, are we okay with that? I know you're finding that a bit funny. All right? So therefore, the sine rule is, so when using the sine rule to find a side length, we use A over sine A equals B over sine B. Now, if I, that original triangle, if I decide to redraw it and use, also include C and sine C in the equation, I would find that I could also get equals C over sine C if I wanted to do it, okay? So when using the sine rule to find a side length, we use this version of it. A over sine A equals B over sine B equals C, little c over sine C. It's just a ratio. The ratio of the side length over sine of the angle equals the ratio of the side length over sine of an angle. Now, girls, just keep listening. Once I start doing examples, you'll get what I'm doing. Okay? So, little a, lowercase a is the side length, capital A is the angle. So whenever you want to use the sine rule to find a side length, we use either the A with the C's or the B's with the C's or the A's with the B's. You've never seen an equation with two equal signs in your life. We're not going to start doing that now. But you know how there's three side lengths of a triangle? You will only use two together. You'll either go A over sine A equals B over sine B, or you'll go A over sine A equals C over sine C, or you go B over sine B equals C over sine C. You only use two of them. Now, we use this version when we're trying to find side length. Why? Because side length is on top. Little a, little b, little c are on the numerator here. That's how you use that version of the sine rule. And you're all probably thinking, what is she going on about? What's the other version? Well, the other version of the sine rule is to swap. If I swap up here the little a and the sine b, and the little b and the sine a, I would have the sines on top. So you can also use the sine rule as follows. When using the sine rule to find an angle, we use the other version, which is the flipped version of this. You go capital sine A over A equals sine B over B equals sine C over little c. So remember capital A, capital B, capital C are on the numerator here. In other words, girls, whenever you're trying to find something with trig or whatever, we like to have what we want to find on the numerator. So if you want to find the angle, if we're doing a question on finding an angle with the sine rule, you put the angles on top and the side lengths on the bottom. If you want to use the sine rule to find a side length, let's put the side lengths on top and the angles on the bottom. Again, with this one, you would only use 2 of these at a time. Either the first pair, or the first one with the last one, or the middle one with the last one. Now that we know what the rules are, we're going to see how we use them. So, capital A, lowercase a is opposite it. Capital B, lowercase b is opposite it. Capital C, lowercase c is opposite it. Notice that capital A and lowercase a are opposite each other. Do you see that? Notice that capital C, angle C, and lowercase c are opposite each other, right? And notice that capital B and lowercase b are opposite each other. And I'm drawing these double-sided arrows for a reason, okay? I'm drawing them for a reason because whenever you see a question with a non-right angle triangle, I'm going to get you to draw double-sided arrows between the sides and the angles that you have. You will never have, see, I've got 6 things here. I've got capital A, capital B, capital C, lowercase a, lowercase b, lowercase c, but you're not going to have 6 of them. You're only going to have 3 things, and they're going to ask you to find the 4th one, and 2 of those will be blank, okay? So notice that they are opposite each other, okay? Now we will do a question, all right? Let's say I have a triangle. This is about 80 degrees, and let's say this angle here is 60 degrees. And let's say that this side length here is 10 centimeters. I want you to find x. Now, it is a non-right angle triangle. For a start, let's just double check. 80 and 60 is 140. This remaining angle here is 40 degrees. This is definitely a non-right angle triangle. Now, so you have to decide, you know, I can't use SOHCAHTOA. There is no right angle. I'm not going to start drawing in right angles and making right angle triangles. So let's see if I can use the sine rule here. So notice I don't have the 3rd angle and I don't know anything about this other side. I've got 3 pieces of information and 1 unknown. See, when you use the rule A on sine A equals B on sine B, that's 4 things that you have to, that are there in the equation. You will know 3 and you will need to find 1. So, do I want to see if I've got any pairs, any opposite sides with their opposite angle. Do I have a pair? The 80 degrees is a pair with the 10, and the 60 is a sort of pair with the x. It's a pair because I'm asking you to find x. See, I'm asking you to find x, and you've got the 60 degrees opposite it. You've got the 10, and you've got the 80 degrees opposite it. So I'm going to use the sine rule, which is A over sine A equals B over sine B. Now, I am not going to go labeling these sides. It would be a nightmare if you start labeling which one's A, which one's B, which one's C. You'll get yourself all confused. So all you want, all this is telling you, it's a little formula. We want the side length over the sine of the opposite angle equals side length over the sine of the opposite angle. Whenever you're doing something like this, let's put the unknown first. So the unknown is x. So what will I do? X over what? Sine 60 equals, do I have another pair? See, side length over sine of opposite angle equals side length over sine of opposite angle. What do I do now? 10 over sine 80. And now rearrange it. If I want to get x on its own, it's x divided by sine 60. Opposite of divide sine 60 is? So I go 10 over sine 80, sine 80 times sine 60. And could someone please work that out? Now, so girls, you just look, you use your pen and you look for pairs. It's as simple as that. 10 and 80 are a pair, 10 and 80 degrees, x and 60 are a pair. Why aren't I doing blank and blank? Because they're blank and I've got nothing to substitute. Pointless. All right? Don't go labeling capital A, capital B, capital C, lowercase a, lowercase b, lowercase c, because you're going to be stuck. It's just much better to know the rule, look for opposite and pairs. That's it. I want the side length. You always put what you want first on the top left-hand side. X over sine 60 equals 10 over sine 80. All right, who's worked it out? Make sure your calculator is in degrees. When you have a bigger angle, it opens up more. 10. When you've got a smaller angle, it opens up less. Should x be greater than or less than 10? Is x bigger or smaller than 10? Small angle, big angle. That's the side opposite. What's it going to be? It should be smaller. See, girls, if you've got a big angle, the side opposite it, because the angle opens up, the side opposite it is a larger length. We're only opening up 60 degrees here. X should be smaller than 60, and if it's not, you're doing something wrong. So what have we got? 8.79. So let's just go 8.8 to 1 decimal place. Okay? Right. That is finding a side length. Okay? We'll do an angle. So that was to find example on finding a side length. Okay. Actually, I'll do another example of finding a side length. Oh, no, I'll do finding an angle. Finding an angle. Let's go to 60, 70. No, not 70. 60. Let's go 15. I'm going to go 17 theta. Okay. Finding an angle. Again, we look for pairs. Can you see two pairs, and in the second pair we need to have an unknown? Do you have a full pair? What I mean by a pair is the angle and the side opposite it is a pair. Do we see a pair? Yes. Which ones? Good. Do you see another pair just with one of them unknown? Good. Are you finding a side length or an angle? So you put the angle one on top. So you use the formula this way. Sine A over A equals sine B over B. Do you get what I'm doing? If you want the angle, put the angle on top of the formula. Flip it. Is it always sine? Yes, it's always sine. It's the sine rule. So what's the unknown? No, that's okay. What's the unknown? Which one's unknown? 60 or 15? Sorry, theta or 60? What's the unknown? Theta. So that goes first. Sine of theta over what? 17. Over 17 equals? Sine of 60 over 15. So sine of theta, how do I get rid of this divide by 17? Times 17. Now that's sine of theta. You're going to get a decimal answer between 0 and 1. And you'll understand why later when we sketch curves, but we're not sketching curves yet. So, girls, this is not the angle you're finding. This is sine of the angle. Do not go rounding off any answers. So sine of theta is what? 0 point what? Please do not cancel that out. You go inverse sine answer equals. Got it? What do you get? Ah, wait a sec. Theta, 17. Do we expect theta to be bigger than 60? 17 is bigger than 15. So 17 will be opposite a bigger angle. It's going to be slightly bigger than 60. I'm guessing about 65. I don't know. Tell me. What do you get? Oh, bigger. Could be 78. What are you getting? What are you getting? Can I have, all right, 78.96? 78.96 degrees. That is a decimal answer. Can I have that to the nearest degree? 79 degrees. See, 78.96 degrees is like 78 degrees 50-something minutes, all right? Because 0.96 is out of 100. That is the decimal degree. That is not in degrees, minutes, and seconds. That's decimal. So 79 degrees to the nearest degree. Okay. Finding a side length, not so obvious this time, and extra step needed. So girls, can you see one pair at least? Good. I can see the 75 with the 12. That's a pair. I'm not being asked to find this side, so don't start drawing up pairs with the 65 degrees and its opposite side. I don't need it. I need the x. So I need x's opposite angle. Can I work it out? Yes, because the opposite angle is 180 minus 65 minus 75. So girls, sometimes, so just look for a pair. So we always look for sine rule first. You are going to learn about cosine rule next lesson, but we always look for sine rule first. So there's an opposite. So I need the x. I need to see if I've got the opposite angle. I don't seem to have it, but I can work it out because there's 180 degrees in a triangle. So we've got, what is it? And I know it's not to scale. 40. So 40 degrees. So therefore, this angle in here, we've just worked it out, it's 40 degrees. So, which version of the sine rule do I use? A over sine A equals B over sine B. So I want to use this version. A over sine A equals B over sine B. All right, what's going to be my A? Don't label them, just side length over sine of angle. What am I trying to find first? X over sine 40. Please, I need to see double-sided arrows on everyone's books, all right? So x over sine 40 equals, what have I got? Another pair. 12 over sine 75. So therefore, x equals 12 over sine 75 times sine 40 is 7.9. Actually, can I have that to more decimal places, please? Well, therefore, let's just give it to 8.0 to one decimal place. Okay. Okay, girls, this one's not so obvious again. Extra step needed. Find this angle. So what we do is we do our pairs. I've got one pair here. I can't find this angle, but which angle could I find? That's a definite pair. Which angle could I find? I know this one. Can I find this angle? Girls, when I use sine rule, there should be 3 knowns and 1 unknown. I'm going to call this angle capital A. All right? Actually, I'm going to call it alpha, little alpha. It's about time you started learning how to do those. Little alpha. It's the Greek symbol for alpha. So I'm not even going to put an A there. So girls, there's theta. We all use theta. Well, here's alpha. You're going to start using that a lot. So it looks like this. That's alpha, like a little fish without don't close his tail. All right? So it looks like that. That's alpha. Okay? So draw that. How am I going to find the pair? I can't pair this theta up with anything. There's nothing to pair it with. If you do decide to find this here, you're going to find a side length, not theta. And then what are we going to do? Not much. So we're going to find alpha instead. So what do? I'm going to use this version. Sine A over A equals sine B over B. Let's go. What do? Sine of alpha over, guys, 8 equals sine of 40 over 6. See, girls, once you know two angles in a triangle, you use angle sum of triangle to work out the last angle. So, sorry, this question should have said find theta, all right? I don't want to find this side length down here. So I'm not going to go 6 over sine 40 equals x over sine theta. I'll have two unknowns. I can't do it. But I can use that as a pair, and this I will use as a pair because one of them is known and the other is unknown. So you'll have a complete pair and half a pair. All right? So how do I do this? Sine of alpha is sine of 40 over 6 times 8. Sine of alpha. Please keep writing sine of alpha. Otherwise, you're going to think you've got the angle when you don't have the angle. So sine of alpha, you should get an answer between 0 and 1. Just keep them about 4, but we go dot, 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 and we're not cancelling. Dot, dot, dot. You put the dot, 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 meaning there are more numbers on my calculator, but I'm just not going to write them all, but I know they're there. All right. Theta, alpha, sorry, is sine to the minus 1 of that. You do not cancel it out. You go shift, sine, answer, equals. Otherwise, you're going to have a rounding error. Otherwise, you've got to write down every single decimal place. What do you get? 58.9869, etc. degrees. Can I have that to the nearest degree? Nearest degree? Yeah, 59 degrees. Therefore, how do I find theta? It's just angle sum of triangle. 180 minus 59 minus 40. 81 or something? 71? I don't know. Someone work it out. That's nearly 100 off it. 81. So therefore, theta is 81 degrees. Okay?